Okay, so yesterday we started on section 9.1, which was talking about our three-dimensional figures. We started talking about three-dimensional figures. So they have like your length, your width, and your height. Okay, our regular stuff that we had talked about before just had like length and width. So now we're talking about three dimensions. On our three-dimensional figures, remember I had several of them. Okay, we have these, you have your different shapes, okay? This is what I mean by three-dimensional, okay? So that's what we've been working on. Now, we did most of the problems from section 9.1 yesterday together in class. We had done 1 through 7, we'd finished that. We had done 13 through 23 and 28 through 31. Because we had skipped number 23, but we went back and did it at the end. So we still have 34, 39, 40, 43, and 44 to do. So that's what we're beginning with today, is finishing section 9.1. So these problems, just drop my paper. These problems are on page 402. Okay, so number 34 goes back to what we were doing at the end of class yesterday. Remember down on like 28, 29, 30, 31, if you look back at those, we were using Euler's formula and the fact that each edge is the intersection of two faces to find the number of vertices for each convex polyhedron. Okay, so with that, like if it said it had 8 triangular faces, you took 8 times 3 because there's 3 sides in a triangle. Okay, so that's what we were working on. So we're going to do that same concept for number 34. It says there's 11 triangular faces. So if there's 11 triangular faces, that means we're going to take 11 times 3. Okay, so I have 11 times 3 divided by 2. Well, hopefully you all know 11 times 3 is 33. 33 divided by 2
is 33 divided by 2, 16.5.
16 and a half, right? 16.5. Now, remember, this is what we were doing to find the number of edges. Okay, now remember an edge is one of these sides. Okay, so it's a straight line that connects where two faces connect. Can you have half of an edge? Can it just go right here and then stop?
No.
No, you can't have half an edge. In the directions, it was saying, why is it impossible to have a common polyhedron with a total number of faces as defined? Because you can't have half an edge. So that's why. This right here, we say can't be a decimal. Okay, it can't be a decimal. You can't have part of an edge. It has to be an integer. Okay, a whole number. It can't have a decimal on it. Okay, so that's all we had to do for number 34. Okay, so that was pretty easy. Now, for 39 and 40, what it's wanting us to do is it gives you a bunch of different nets there. Remember, nets are what you get when you take all the faces of the prism, whatever pyramid, whatever it is, and you lay them out flat, okay? So this is a net, okay? See, it's a net. Now, with the net, on number 39, it says which 2 nets that are up there above, there's 8 listed in your book, which 2 of those cannot be folded to form a cube? So first of all, cube has how many sides?
8.
Cube has 6 sides.
Oh, 6 sides.
Top, bottom, left, right, front, back. They're all the same size, okay? So it has to have 6 sides that they could fold together to make that cube. So you just gotta look at the pictures. Now this is my net from my cube. So you kind of get an idea. To be able to fold into the cube, you need 4 that are going out long for the most part, and then 1 on either side to be able to make the cube. Because you have your 4 going out long because they can fold up and make that part, and then you have the 1 on either side to finish closing it off. So on part A, would that one make a cube?
Yeah.
Yes, because you got your 4 long ones and it would fold down. What about B? Is it going to make a cube?
No.
No. So B will not make a cube. Okay. C, you have 3, and then the way the others are, you could still make that one work. D is pretty much like A, so that one would work. E, you have the 2 that are there next to the top. You have 3 in a row. I think we could make that one work. What about F though, where there's 3 side by side? That gonna work?
No.
No. So the 2 that won't work are B and F. So for number 39, all you have to do, put B and F, and that's it, okay? For 40 it says, which 2 nets are the same pattern, just flipped or reversed? So which 2 look almost exactly the same? Which just flipped around?
And D.
A and D. Okay. So that's it. So that's all you have to do for 39 and 40. Pretty easy.
Yeah.
All right. Now 43 and 44 are still talking about nets. Okay, but we got to read the situation there. It says, traditionally, the numbers on opposite sides of a die, y'all know what dice are, right? You've played a game before, you've seen dice, okay? The number on opposite sides of a die have a sum of 7. So that means if I've got 2 on one side, the side opposite would be
The same.
5, because 2 plus 5 equals 7. So that means 2 is going to be opposite of 5. 1 would be opposite of what? 6, because 1 plus 6 is? Okay. All I'm asking you to do is add, people. That's it.
7.
Okay? 7. The numbers that are on opposite sides of the die. So opposite means front and back. So if this was a 1, on the back would have to be the 6, because 1 plus 6 equals 7. If the top was 3, the bottom would have to be 4, because 3 plus 4 equals 7. Okay, the numbers that are on opposite sides have to equal 7. Okay, so
Good morning, Miss.
What?
Hey,
Hello.
I'm late, but I'm here.
Yeah, I know. All right, we're on number 43 from yesterday on page 402.
All right.
Such an arrangement forces the faces representing 1, 2, and 3 to share a common vertex. So that means they all touch each other at one point. Okay? The die is left-handed if they are arranged in a clockwise order around the common vertex. And it is right-handed if they are arranged counterclockwise. So, Clockwise goes around this way. Javier, whatever you were doing, you need to put that away and focus, because that's not what everybody wants to see. Monica, I still can't see you. You like hiding in the dark. All right, Pedro, get your camera up there. All right, so clockwise goes around the way a clock does, counterclockwise goes opposite, okay? So
It's not turning on, Miss.
on number 43, it says, which of the following nets could be used to make a traditional die? So remember, first of all, the 1, 2, and 3 have to be next to each other. So are they next to each other in A? Are the 1, 2, and 3 where they share a vertex, where they touch at a corner?
Yeah.
Yes. Okay. And the 1 would be opposite the 6 when you folded the sides in. The 2 would be opposite the 5. 3 would be opposite the 4. So A will work. Will B work?
No.
Okay. I heard no because our 1, 2, and 3 share in a vertex?
No.
No. On C, are 1, 2, and 3 share in a vertex?
Yes.
If you look at them, you've got 1 and 3 there together, and then when you fold 2 around, it's going to touch, but are the right sides going to be opposite of each other? Because the way it is right now, when I fold those in, it looks like my net I have here. Okay, it kind of looks like the cross. All right, you've got 3 here and 6 here. So 3 and 6 are opposite of each other. Does that add to 7?
No.
No, that adds to
No.
9. So that's not it. So on D, D, you've got 2 and 5 are on these sides, so that would add to 7. You have 6 here, so when I fold this bottom part up around, I have 1 opposite it. And the 1, 2, and 3 will actually end up touching. So D is the other one that would work. So it's A and D. And then for 44, it says, which of the following nets would form a right-handed die? A right-handed die. So that means the 1, 2, and 3 are kind of going clockwise when you put them together. Well, I'll tell you it's not A because they're all kind of there. It would be on the left, going around for them. What about B?
Maybe.
Yes.
Yeah.
And C. B and C are the 2 that would make it. Okay. So make sure you've got your answers down. That finished at 4:02. And then told you we're going to be starting on this today. This should be in your orange folder. Prisms on the front, cylinders on the back. Prisms on the front, cylinders on the back. So find that worksheet and get it out. We're starting to talk about it. Okay. Everybody get that out.
I'll be right back. I have to go to the other room.
All right. So, everybody found their worksheet if you had your folder? Okay. Now, in your folder, you also had a paper that had like some formula sheets on there, but you've got them on the top of this worksheet too, so you shouldn't have to have something else. It was on your notes that you were supposed to have worked on filling in, but it's got them right here at the top of the worksheet too. okay? We're going to be talking about 3 different things. We're going to be talking about volume, which is how much would fill up the 3-dimensional figure. If I was trying to fill it up with sand, with water, whatever, okay, what would go inside of it is its volume. We're going to talk about lateral area, which is the area around the sides, and then we're going to talk about surface area, the total surface area, which is the area of all the sides together. Now, most of our prisms that we're doing on this worksheet are shaped like this, okay? This is a square prism. The base is a square, okay? And you have the rectangle. Or you can call it a rectangular prism, because remember, is a square a type of a rectangle? Yes.
Yes.
So you can call it a rectangular prism if you want, same thing, okay? The base is a rectangle, and then the other sides that connect the 2 bases together are also rectangles. So if I am talking about the volume, I'm trying to fill this container up on the inside. If I'm talking about lateral area, I'm talking about the area of the rectangles going around connecting the 2 bases together. It doesn't include the 2 bases. The lateral area is the sides area, the sides connecting the bases. If I want total surface area, the whole thing, if I was covering it with wrapping paper, that's your total surface area. I have to cover all 6 sides. That's the lateral area around those 4 rectangles plus the area of the 2 bases, the top and the bottom. So that's what we're going to be working on these. We're going to have 3 answers for each one. Okay? We're going to have 3 answers for each one. We're going to do our volume, we're going to do our lateral area, and we're going to do our surface area. We're going to do some on the prism side and some hopefully on the cylinder side. I'm going to just do like at least a few of each of both today, and then we'll work some more tomorrow. Okay? So it told you on the top of your worksheet for volume, it's the area of the base times the height of the prism. Okay, now most of these I told you were rectangular prisms. The base shape is a rectangle. Okay, it's the part that the box is sitting on, basically. That's your base. So remember, if it's a rectangle, the formula for the area of a rectangle is what? Length times
width.
Width. So most of them that we're going to be talking about for your volume, you're going to take length times width times the height. Okay, so that's for the volume. So we're going to go through and look at that for number 1. Okay. Our volume on number 1 is my length of my rectangle on the bottom is 5. My width is 2. And then the height of the prism is 3. So all you do is you do 5 times 2 times 3. So 5 times 2 is 10, 10 times 3 is
30.
Okay, all we're working on right now is just talking about volume. Okay, get one formula down at a time before we do another one. Everybody good with that? Okay, now, you don't have a whole lot of room to work on here. If you look, see, I did all my work out on a separate sheet of paper. See? You can't see that though, you can't get the answers, no. Okay, so, but that's what we do. We're doing volume.
Can I see, Miss?
Yeah, see, yeah, All right, so number 2, is its base a rectangle? Number 2, is its base a rectangle? What?
Yeah.
No, what side's it pointing at?
Oh.
It's pointing at the triangle, right?
Yeah, I didn't see that.
Yeah. It's pointing at
Yeah.
the triangle. So it is a triangular prism. It's like this one. My base is the triangle there on the front, and then the rectangles are the sides, okay? But the bases are the triangles. So you still do for the volume. Volume is still area of the base times the height. Volume is still area of the base times the height. Who remembers how to find the area of a triangle?
Area, no.
Base times height.
Area S times 4.
No. Area of a triangle.
There it goes.
1/2 times the base times the height. Okay, I heard base times height, but I didn't hear the 1/2 part. Okay, so our base on this one is a triangle. So to find my volume, I take the area of the triangle, 1/2 times base times height, times this height, which is talking about the height of the prism. The height of the prism connects the bases together. So in this case, it connects the triangles together. That's how you figure out which height you're talking about. Okay? Now, on a triangle, your base and height here are always perpendicular to each other, which means they make what? They're perpendicular, they make a what?
Right angle.
Angle, okay? So that's what we're gonna use for this. So on number two, we're still just talking about volume right now. For number 2, for my volume, I have 1/2 times, what is the base of the triangle base? 3.
3.
The height of the triangle is the side that's perpendicular to it, so that's 4. And then the height of the entire prism is what connects the two triangles together. So my bases are on the front and back, the two triangles. So the length connecting the two triangles together is the little side measurement down here, 2. So that's what we're going to multiply for the volume on number 2. 1/2 times 3 times 4 times 2, which is sorry, my marker's really. What is it? You agree with that? 1/2 times 3 times 4 times 2.
Yeah, I agree with that.
12 times 2 is 24, 1/2 of 24, and over 12. Okay? So right now, all we're talking about is our volume. Okay? Right now, all we're talking about is volume. So if it's got a rectangle base, it's length times width times height of the prism. If it's got a triangular base, it's 1/2 times base times height times the height of the prism. Okay? So if you look at number 3 on your worksheet, is it like number 1 or number 2?
Number 1.
Number 2.
It's like number 2. You got a triangular base again. You have a triangular base on number 2. Now, if you look closely, this has a right angle. It's a right triangle. You have this side is 4. This side is 4 square root of 2. Does anybody know what special type of right triangle that is? This is going back a couple of chapters.
Isosceles?
It's an isosceles right triangle. So that means the two legs are going to be the same. So they're both going to be what?
The same answer?
Same measurement. Which in this picture is, Yeah, this is 4, this is square root of 2, so this side over here will also be 4.
4.
It's a 45, 45, 90 triangle, okay? The base and the height of the triangle, the two that make the right angle, are both going to be 4. The hypotenuse was 4 square root of 2. So on number 3, when I go to find the volume, I'm just doing it over here because it's under the same formula. It's a triangle base. I have 1/2 times the base of the triangle is 4 times the height of the triangle, which was also 4, times the height of the entire prism. What is the little length over here that connects the two triangles together?
Oh, I don't know.
Looking at the worksheet, what's the measurement there connecting the two triangles together?
2.
2.
2. Okay, so you have 1/2 times 4 times 4 times 2. The 1/2 and the 2, hopefully you realize will cancel out. So 4 times 4 is
16.
for your volume. Okay. Is number 4 like number 1 or number 2 and 3?
It's like number 1.
It's like number 1 for rectangular prism. Okay, rectangular prism, remember the volume is length times width times height, correct? So I have length times width times height. So for number 4, my volume is, what is my length across the bottom of the picture?
8.
8. My width going back is 4, and then the height is 2.
2.
So I have 8 times 4 times 2.
Okay.
Good. Now you should be able to do this without a calculator. This is basic multiplication. 4 times 2 is 8. 8 times 8 is
64.
64. Okay. Number
I'm
5,
smart.
like these or like these? Is that rectangular prism or triangular?
I think the prism, the first one.
A rectangular prism. Okay.
Yeah.
So on number 5, for my volume, my length is what number?
Your length is 2.
There's not even a 2 on the picture for number 5.
Oh,
4.
wait, I was the wrong one.
It's 4.
Yeah, 4.
Then my width is
4.
4. 10.
and the height is 4.
4.
Now, technically, it doesn't matter which one you say is which, because does the order matter when you're multiplying?
No, ma'am.
No, but you just kind of need to know which one's which. Your length and width are always, I always use the rectangle on the bottom that it's sitting on as the base. So the length and width are the 4 and the 10, and then the height's going to be the 4. So when you multiply those together, 4 times 10 times 4,
It's 160.
160. Because 4 times 4 is 16 times 10, 160. Okay, so that's volume. Kind of getting the idea about volume a little bit. Okay, number 6. Is it going to be like 1, 4, and 5 or 2 and 3?
2 and 3.
2 and 3. It's a triangular prism. It has the base as a triangle. Now you have to be careful on number 6. They throw in some stuff from previous chapters. If you look at it, remember I said the base and the height of the triangle are always perpendicular to each other. if you look on here, the base and the height would be the bottom side down here where it has the word base. And then the height's going up the side here. That's where the right angle is. I don't know that line going across the bottom here, but it's a right triangle, so I know how to find the missing side in a right triangle. I use Pythagorean Theorem. So on number 6, we have to use Pythagorean Theorem first because I do not know what my base is down here. Okay, I know that my height was 8, and I know this side in the picture was 17. So I have to use Pythagorean Theorem. So I have 8 squared plus b squared equals 17 squared. Next part, we square stuff. 8 squared is 64 plus
64.
b squared, and then 17 squared,
289.
89.
Yep.
You're still getting b by itself. So I subtract 64 from each side. Cancels. I have b squared equals 225.
22.
Is b
Yeah.
by itself yet?
No. Oh, yeah.
No, it's squared. So what's the opposite of squaring something?
Square root it.
Square root it. So the square root of b squared is b. The square root of 225
It's 15.
So my base of my triangle is 15. I had to do that before I can find my volume. Now my volume is equal to 1/2 times the base of the triangle, which we found was 15, times the height of the triangle, which was 8. And then the height of the prism is where the two sides connect, where the two triangles connect. So it's also an 8. It's up there at the top of the picture. So that is what I have to multiply together for the volume on number 6.
I'm back, miss.
Yeah, I know. What do you get when
400.
you multiply that together?
What?
400.
480?
480.
That's a big number.
Okay, so that's your volume. Okay, you understanding how we do volume?
Yep. Just
Okay.
do a pattern
Now,
in the
before we go any further, on the worksheet, down at the bottom, you can see I drew a line through number 11. You can draw a line through number 11. We're not going to do number 11.
Okay.
Okay,
Which one?
number 11.
Oh, okay. I see it now.
On the back of the worksheet, you can draw a line through number 7. We're not going to do number 7 on the back. Okay?
Mhm.
Yep. So everybody got that marked out? We're good with that? Yep.
Round.
All right. So I want to look at the back side for a little bit and talk about volume of cylinders. Okay? Volume of cylinders is the same concept. It's the area of the base times the height. But if you're talking about a cylinder, what shape is the base of a cylinder? What shape is that?
It's a circle.
It's a circle. So we're still doing our volume is the area of the base times the height, but our base is a circle, so we have to use the formula for the area of a circle. When it was a rectangular prism, we did the area of a rectangle times the height. When it was a triangular prism, we did the area of the triangle times the height. So if it's a cylinder, you're going to do the area of a circle times the height. Well, it shows you on the worksheet. To find the area of the circle, it's pi times the radius squared. That's our formula for the area of the circle. So it's still doing the same thing. Cylinder's volume is the area of the base times the height. But it's a circle, so it's pi times the radius squared. Okay, now hopefully everybody knows a radius goes halfway across the circle, correct? That's something everybody should know by now. A radius goes halfway across the circle. Everybody should know that. Okay, so if you look at your picture, do they give you the radius?
Yes, no.
Yes. And then this long one connecting the two circles together is going to be your height. Your height in the prism or the cylinder is what connects the bases together. So on this one, for number 1 on my volume, I have pi times the radius squared times the height. My radius of that cylinder is 3. My height of the cylinder is 7. So it's just pi times 3 squared times 7. Now, order of operations tells me we do exponents first. So 3 squared is?
9.
9.
So 9 times 7 is? 63. And then you just put pi on your answer. Do not multiply by 3.14. Leave pi on your answer. Okay? Do not multiply by 3.14. Leave pi on your answer. Okay? So it's just 63 pi. Okay? So on number 2 for the volume, I have pi times what's the radius in that picture?
8.
8. And then the height?
3.
3. So it's pi times 8 squared times 3. And you just multiply it together. 8 squared is 64. 64 times 3.
Let me put my calculator. 64 times 3. 192.
So it's
192.
192 pi. Okay? Pretty easy? Yes?
Yeah, I like this one more better.
Kind of.
Number 3 for volume. Pi times what's my radius of this cylinder?
5.
5 squared times the height, which is
2.
2. So 5 squared is?
25.
So 25 times 2 is?
50.
And 50.
50. So it's 50 pi. Okay? So you get the idea of these?
Yeah.
Okay? So I'm just hearing the guys, girls, you all got this? Pretty easy?
Yes.
All right. Okay, this is what I'm trying to do, this chapter. Hopefully, if you learn the formula, hopefully it'll be a good unit for everybody. Okay? Let's say number 4. Number 4 for the volume. Pi times what's the radius on that cylinder?
4.
4. What's the height on the cylinder?
4.
So 4 squared times 4.
18. 16, I mean.
So it's 4 squared is 16. 16 times 4 is 64. So it's 64 pi. Okay. Now, number 5 and 6 use something that we already talked about on one of the other problems. Okay, what do you know about all radii on a circle? Are they the same? All radii are what? Congruent. They're the same length.
Yep.
Okay. So if one of them's 3, the other one's 3. All of them are 3. If one of them's 10, all of them are 10. So if you look at number 5, it's kind of hard to tell it because where they drew the 3-dimensional picture, it makes it hard. Okay. I'm going to scroll you all over this way a little bit. Okay. You have like this on the top, but it looks like really squished. because where it's trying to show the three-dimensional figure, okay? But what you got to understand is from this point right here out is a radius. From this point here to the other side is also a radius. They don't look the same length the way they're drawn on the picture because they can't where it's a three-dimensional thing. And then it showed you this side was 3 square root of 2. That is not the radius. But for our formula, we need the what? We need to know what the radius is. So to find the radius, this is just like what we had on that other one. The two sides are congruent, so it's a right isosceles triangle or a 45, 45, 90 triangle. So if it's a 45, 45, 90 triangle, to find the two legs, I can take 3 square root of 2 divided by square root of 2. So both my radius is just going to be 3. Okay. On the other one, we had this was 4 and this was 4 square root of 2, so this side was 4. But on this one, we had the hypotenuse, so we had to divide it by square root of 2 to get the two legs are going to be 3. So after you know that that's 3, you can find the volume. Pi times the radius squared times the height of the cylinder, which is that a 5 on that one?
Yeah.
On number 5, that's a 5. So 3 squared is what?
9.
And then 9 times 5 is
45.
45 pi. So is number 6 going to be the same way?
Yes.
Yes. So for my volume, I'd have pi times my radius is not going to be 5 square root of 2. It's just going to be what? Just the 5. You would divide it by the square root of 2. And then the height is 8.
8.
So where you get?
25 times 8 is
Do y'all agree with that or no? Hmm? All right. So what I want you to do is remember which problems I told you you could mark out. We marked out number 11. And we marked out number 7 on that side. So what I want you to do is try to finish the volume for each one. Just finding the volume. Okay.
okay.
Try to finish the volume for each of those. And then tomorrow we'll talk about your lateral area and your total surface area. Okay?
Yes,
so
ma'am.
everyone knows where their worksheet is. You got it. You've been following along. You've been doing your work. There's not a lot of room on here to do the work, so it's a good idea to do it on separate paper. Okay?
You want us to send it to you when we're done?
So what?
You want us to send it to you when we're done?
You don't have to send that to me when you're done. Some of you still need to send me your test 8.
I do.
Not me.
Mm-hmm.
That's on mine.
I'm more worried about getting test 8 from you all because we're still going to do lateral area and surface area tomorrow on here, and then I'll want to see it all done. Okay? So make sure you finish the volume tonight or this afternoon, and then I'll see you all tomorrow at 11.
Okay.
Okay?
Okay. I'm trying to do everything, miss.
Mm-hmm.
Okay.
Yeah.
That'd be good.
Bye.